So now we're going to talk about what type of roots we have, the nature of the quadratic roots. Okay, your roots are your solutions, your x equals and your x equals. You get two roots for a quadratic. Okay, and generally what we used to know is the roots are where it cuts the x-axis on your graph. Okay, so they would be the roots. Okay, we're going to decide the type of roots now. We used to just, I suppose, learn where they cut the x-axis. Now there's more. Okay, so to decide the nature of the roots, you look at the discriminant. This is called the discriminant. Where have you seen this? It's the part under the square root sign in the minus b formula. Okay, so you look at b squared minus 4ac. Now, I was just talking to someone there. What did I say the bit under the square root can't be? A minus. Okay, because if it's a minus, your calculator can't get the square root of a minus number. But I was talking about it yesterday. We're moving on to a chapter, probably after Christmas, called complex numbers. So we've got real numbers and we have imaginary numbers. Okay? Square root of a minus number is a complex number. We'll deal with it way more in that full chapter, but for the minute, if b squared minus 4ac is a minus, it means you have complex roots. Okay? We can have real roots, like we're used to, two separate roots, real and distinct. We can have real and equal. Real and equal roots means the root is the same. Okay, so x equals 2, x equals 2. That's real and equal. Real and distinct would be two different roots. Okay, you can have complex roots up there. Okay, complex roots wouldn't cut the x-axis. So we need to decide the nature by looking at b squared minus 4ac and deciding, is it equal to 0, is it greater than 0, is it less than 0? We have to learn this off. Okay, so the first thing we're going to do is real and distinct, or real and different roots. Two roots that are different. Okay, real and distinct roots. That happens when b squared minus 4ac is bigger than 0. That's what real and distinct roots would look like on a picture. The next one is real and equal roots. That means you get two answers for x, but the answer for x is the same. So it just sits on the x-axis. Okay, so real and distinct roots is greater than 0. Real and equal roots is equal to 0. Okay, the bit underneath the square root is 0. We're not actually doing the minus b formula. Okay, the question will be decide whether or determine the nature of the roots of this quadratic. Okay, they're not actually asking us what are the roots, it's just decide what type of roots they are. Okay, are they real and distinct, are they real and equal, or are they complex? Okay, so it's kind of a separate part to the question. If they're complex roots, we know underneath the square root sign has to be a minus, and a minus would be less than 0. The last one, it doesn't come up as much, is rational roots.
Makes it the roots are less than 0? Should it not be below the x-axis?
No, it's these aren't the roots. This is the discriminant is less than 0. Okay? The thing under the square root is less than 0. If you were to actually plot the roots of a complex number, you can't do it on an x and y plane. Okay? So complex numbers is on a different plane. It's z's. So you wouldn't even see it in a picture. Okay, like this. You don't have to worry about that for the minute. That's a whole other chapter we have to do. Alright? So for the minute, you're only deciding, are they real or are they complex? Okay? And basically, your complex roots will never cut the x-axis. Okay? The last one is rational. You keep doing it underneath. I don't really have room here. Rational roots. B squared minus 4ac is a perfect square, or is a square number. Okay? So underneath the square root sign would be 25, or would be 4, or 9. Okay? So it's a square underneath the square root sign. That's when you have rational roots. It doesn't come up that often. Okay? But we'll do a few examples of these. Now, often the question is, determine whether the roots are real. What are the two scenarios if they're real roots? Yeah, real and distinct or real and equal. So if I'm just interested in real, I'd say b squared minus 4ac greater than or equal to 0. Exactly. Okay, that's really important. So can I get rid of this? Often this is what comes up for real roots. B squared minus 4ac is greater than or equal to 0. Because if it's greater than, they're real and distinct. If it's equal, it's real and equal. If you don't care whether it's distinct or equal, then it's greater than or equal to 0.
There's a rational root, like that, a perfect square, is there no diagram for that?
No. So it can be, see, it can be equal or it could be real. Because it's rational, it means it is real. So there's no particular diagram to match it, no. Okay. Okay, determine the nature of the roots. So if you're asked about the nature of the roots, immediately you just do A is 49, B is 42, and C is 9. And then you go for your formula. So my discriminant is B squared minus 4AC. That's the only part I'm interested in. Okay? And if that's bigger than 0, I know they're real and distinct. If it's equal to 0, real and equal. Less than 0, complex. Okay? So B squared minus 4AC. Okay, and we get 0. So B squared minus 4AC equals 0. What does that mean for the roots? Real and equal roots. Okay, therefore, those three dots mean therefore real and equal roots. Equal roots means the roots are the same. So you could say identical roots. Okay? Real and equal is fine.
Do we have to learn these equations in the log?
Well, the minus b is in the...
Oh, yeah.
So, no, you need to learn the discriminant and the greater than, less than, and what it means. Now, do another example? Okay. Can I get rid of this? Now, this question says, find the value of k so that this thing has equal roots. For writing the formula for equal roots, you're already getting yourself 3 out of 10. So that's why it's so important to learn these off. So to show that they have equal roots, what do you do? B squared minus 4ac equals 0. See how easy that is to get the marks. Okay? So you're writing everything down. Now, we need to fill in. In this case, what's your A, your B, and your C? A is good, the number with the x squared, minus 2. B is k, and C is minus 8. So you're going to fill that in. B squared minus 4ac, and it's equal to 0. Minus 4 by minus 2 is 8. 8 by minus 8 is minus 64 equals 0. Can I make a slight adjustment to the question? Sorry. Values of k. So 2 ways you can do this. You can bring the 64 over, and then you need to remember that it's plus and minus, or what's the other way? Difference of 2 squares. Okay, so totally up to you. Maybe you immediately see it this way. If you do, you have got to remember that the square root of 64 could be 8 or it could be minus 8. Okay?
If it didn't say values, would you just say that it's plus?
You'd probably find both and then fill it back in and see which one. Yeah.
Why did you X
I wrote it down wrong is all. Like it was values. I had just written value.
No, but I mean, like, why is X and minus? Or plus and
Why is it plus and minus? Because minus 8 to be squared is what?
64.
Yeah. And 8 to be squared is 64. So if k squared is 64, k could be both of those things. Okay? We don't know, so you've got to take both. Any issues with that? Okay. So let's just do one more.
That's just the middle of the It's not. I think that's the break.
Yeah, you're having break now, are you?
Yeah. Oh.
Sorry.